Now next communication protocol is Bluetooth. Now here we will see how Bluetooth protocol is used and implemented and how it works. Okay. So see, first of all, the question is what is Bluetooth? Okay. So here Bluetooth is a standardized protocol for sending and receiving data via a 2.4 gigahertz wireless link. Okay. So here it is a secure protocol and it's perfect for short range, low power, low cost wireless transmissions between electronic devices. Okay. Now, symbolically in your mobile, you can see the Bluetooth protocol will be shown as shown in the diagram. Okay. These days, it feels like everything is wireless, and Bluetooth is a big part of the wireless revolutions. You will find Bluetooth embedded into a great variety of consumer product like headset, video game, controller, or of course livestock trackers. In our world of embedded electronics hackery, Bluetooth serves as an excellent protocol for wirelessly transmitting relatively small amount of data over a short range, less than 100 meter. It's perfectly suited as a wireless replacement for serial communication interface. You can use it to create a DI-HID computer keyboard, or with the right module, it can be used to build a homebrew wireless MP3 player speaker. So I hope in market you can see these kind of applications are getting okay. Most of the wireless speaker. Okay, similarly the livestock trackers point of view or many video games, or you can find Bluetooth based your headsets are there. Similarly, you can watch Bluetooth based many domestic appliances are also there. Okay, these are designed with the help of Bluetooth based protocols. Now we will see what is the Bluetooth in detail. Okay, see, it is a wireless personal area network technology and is used for exchanging data over smaller distance. This technology was invented by Ericsson in 1994. It operates in the unlicensed industrial, scientific, and medical ISM band at 2.4 GHz to 2.485 GHz. Maximum devices that can be connected at the same time are 7. More than 7 are not possible, so that's why it is a feature of this protocol. It has range up to 10 meters. It provides data rates up to 1 Mbps to 3 Mbps. It depends upon their versions. The spreading technique which it uses is frequency hopping spectrum. A Bluetooth network is called piconet, and it is a collection of interconnected piconet. It's called scatternet. Now I am showing you the Bluetooth architecture. The Bluetooth architecture is defined by two types of network like piconet and scatternet. So we discuss what is piconet and scatternet. Now here this slides is showing you the piconet and scatternet are present. So piconet 1 and Piconet 2, both are shown in the bottom diagram. You can see M1 is the first one, mobile or a primary node. You can say it is a primary node. Okay, and the slave, that is S1, S2, S3, S4. Okay, so it builds a Piconet 1. But if you look, S4 is a node is sharing Piconet 1 and Piconet 2. In Piconet 2, you can find M2 will be another master, and it has nodes like S4, S5, S6 and S7. Okay, so here both Piconet are called scatternet. Okay, now see what exactly means Piconet. Piconet is a type of Bluetooth network that contains one primary node called master node and seven active secondary nodes called slave nodes. So here M1 is referred as primary node and S is referred as slave nodes. So maximum there are seven slave nodes will be handled by a primary node. We can say that there are total active nodes which are present at a distance of 10 meter. The communication between the primary and secondary node can be one to one or one to many. Possible communication is only between the master and slave. Slave to slave communication is not possible. It is also having 255 park node. These are secondary node and cannot take participation in communication unless it gets converted to the active states. Means when you form a network, then there are total 255 nodes provision will be available for nodes, but out of that only sevens are active and remaining are not active nodes. Okay, now we see what is scatternet. It is formed by using various piconets. A slave that is present in one piconet can be acts as master, or we can say primary in one piconet. This kind of node can receive message from master in one piconet and deliver the message to its slave into the other piconet where it is acting as a slave. This type of node is being referred referred as bridge node. A station cannot be a master in two piconet. So this is about the scatternet. Now we see how Bluetooth will work. So here a master and slave combination is shown in the bottom side diagram. Okay, here one master and one slave will be there, or one master and multiple slave will be there. But you cannot see two master and multiple slave. Okay, in a network, in a piconet, I show you only one master and multiple slave are there. So the Same combination is adopted here while explaining how Bluetooth will work. The Bluetooth protocol operates at 2.4 GHz in the same unlicensed ISM frequency band where RF protocols like Zigbee and Wi-Fi also exist. There is a standardized sets of rules and specifications that differentiates it from other protocols. Now we see masters, slaves, and Piconet. Bluetooth networks, commonly referred to as Piconet, we use a master or slave model to control when and where devices can send data. In this model, a single master device can be connected to up to 7 different slave devices. Any slave devices in the Piconet can only be connected to a single master. Example of Bluetooth master or slave Piconet topologies is shown below. The master coordinates communication throughout the Piconet. It can send data to any of its slave and request data from them as well. Slaves are only allowed to transmit to and receive from the master. They cannot talk to other slave in the Piconet. Now we see the Bluetooth addresses and their names. When you see any Bluetooth device, then over that you can see something will be written. Now I am explaining what is that, what exactly it means. See, here a picture is shown in that something is written like MAC number, FCC ID, IC, all these things that I am telling you here, why and what is its purpose. See, every single Bluetooth device has a unique 48-bit address, okay, commonly abbreviated BD underscore address. This will usually be presented in the form of 12-digit hexadecimal value. The most significant half 24-bit of the address is an organization's unique identifier which identifies manufacturer. The lower 24-bit are the more unique part of the address. This address should be visible on most Bluetooth devices. For example, RN42 Bluetooth model. The address printed next to MAC number is 000666422 Here 0000666 portion of that address is the OUI of roving network, the manufacturer of the model. Every RN module will share those upper 24-bit. The 422.152 portion of this module is the more unique ID of the device. Okay. Now, when you find one device is paired with another one, then how you can see over your mobile or any devices. Here you can see a screenshot of that particular device which are linked, which are get paired. So here one device is paired with another one, or one device master is paired with multiple slave devices also. See, Bluetooth devices can also have user-friendly names given to them. These are usually presented to the user in place of the address to help identify which device it is. The rule for devices names are less stringent. They can be up to 248 byte long, and two devices can share the same name. Sometimes the unique digit of the address might be included in the name to help differentiate the devices. Now, what will be the connections process adopted between the two devices? Okay, so see, I'm telling you here, creating a Bluetooth connection between two devices is a multi-step process involving three progressive states. First is inquiry. If two Bluetooth devices know absolutely nothing about each other, one must run an inquiry to try to discover the other. One device send out the inquiry request, and any device listening for such a request will respond with its address and possibly its name and other informations. So this is about the inquiry carried by the devices. Then paging means connecting. Paging is the process of forming a connections between two Bluetooth devices. Before this connection can be initiated, each devices need to know the address of the other found in the inquiry process. Okay, and last step is connections. After a device has completed the paging process, it enters the connection state. While connected, a device can either be actively participating or it can be put into a low power sleep mode. Here, following modes you can observe while doing connections. First is active mode. This is the regular connected mode where the device is actively transmitting or receiving data. Second is sleep mode. This is a power saving mode where the device is less active. It will sleep and only listen for transmission at a set interval. Example, every 100 milliseconds you will find sleep mode. Then hold mode. In hold mode is a temporary power saving mode where a device sleeps for a defined period and then return back to active mode when that interval has passed. The master can command a slave device to hold. And last is park mode. Park is the deepest of sleep mode. A master can command a slave to park, and that slave will become inactive until the master tell it to wake back up. So these things you can find under the connections process. Now, how the bonding and pairing is carried out between the two Bluetooth devices. See, when two Bluetooth devices share a special affinity for each other, they can be bounded together. Bounded devices automatically establishes a connection whenever they are close enough, means within the range of 10 meters or less than 10 meters. When I start up my car, for example, the phone in my pocket immediately connects to the car's Bluetooth system because they share a bond. No UI interactions are required. Bonds are created through one-time process called pairing. When devices pair up, they share their addresses, names, and profiles and usually store them in memory. They also share a common secret key which allow them to bond whenever they are together in the future. Pairing usually requires an authentication process where a user must validate the connections between devices. The flow of the authentication process varies and usually depends on the interface capabilities of one device or the other. Someone pairing is a simple just work operation where the click of a button is all it takes to pair. This is common for devices with no UI like headset. Okay, in terms of headset applications, devices, such type of carry action is not carried out. Other times, pairing involves matching 6-digit numeric codes. This is older legacy. Pairing process involves the entering of a common PIN code on each device. The PIN code can range in length and complexity from 4 numbers. Example 0000 or 1234 to a 16 character alphanumeric string. Now there are these power classes that you can see with these Bluetooth devices. The transmit power and therefore range of a Bluetooth model is defined by its power class. There are three defined classes of power. Some models are only able to operate in one power class, while others can vary their transmit power. Here I given one table. In that, 4 column I given. First is class number, then maximum output power in dB, and third column is showing max output power in milliwatt, and the maximum range is shown. Means as per the power, as per the classes, you can find the range of Bluetooth devices. In class 1, you can see 20 dB meter, maximum output power. Similarly, 100 milliwatt power will be there, and it is for 100 meter maximum range. Class 2 is used for 10 meter. It has 2.5 milliwatt power. And class 3 is 10 centimeter. it required 1 milliwatt power. Now, now I'm giving you the protocol stack. To continue with your Bluetooth communication, now uh, this section is based over the Bluetooth protocol stack. Okay, this is the internal structure of Bluetooth. Here you can see in the bottom there is a radio. Above that there is a base link controller, then a link manager protocol, then logical link control and adaptation control. It is distributed into three things like TCS, then RF communication. RF communication has OBEX and WAP, and last is HDP. All these are meeting to applications. Now we see one by one what is this. Okay, so I'm going over the next one slide. See, first one is radio layer. We will say it is a RF layer. What is the function? It performs modulations, demodulations of the data into RF signal. It defines the physical characteristics of Bluetooth transceiver. It defines two types of physical link: connectionless and connection oriented. Okay, so this is about the RF layer. Above that there is a baseband link layer. Its purpose is to perform the connections establishment with the Piconet. Okay, then third thing is coming in picture is link manager or protocol layer. It helps to perform the management of the already established link. Also, it includes authentication and encryption process. Then logical link control and adaptation control protocol layer will be there. It is also known as the heart of the Bluetooth protocol stack. It allows the communications between the upper and lower layer of the Bluetooth protocol stack. It packages the data packets received from the upper layer into the form expected by lower layer. It also performs the segmentation and multiplexing. Then next is SDP layer. It is short for Service Discovery Protocol. It allows to discover services available on another Bluetooth enabled devices. Then RF communication layer. It is for radio front end component. It provides serial interface with WAP and OBEX. Now we see what is WAP and OBEX. OBEX means object exchange. It is a communications protocol to exchange object between two devices. And WAP means wireless access protocol. It is used for internet access. Then TCS is their last one layer, that is below that application. We say it is a telephony control protocol. It provides telephony services. And last is application layer. Its purpose is to enable the user to interact with the applications. So this is about the Bluetooth stack. Now we see the compare between the Bluetooth, Zigbee and Wi-Fi. Okay, at this moment I have not shown you anything about the Wi-Fi, but now here in comparison I am taking it for comparisons purposes. So at least you should know how you can do the comparison in our these things. So here you can see Bluetooth Classic in first column, then Bluetooth 4.0 low energy will be in second one, then third is a Zigbee, and fourth one is Wi-Fi. Okay, now here all are following the IEEE standards, but here while following the IEEE standards are dependent on the technology. So Bluetooth Classic and Bluetooth 4.0 both are using 802.15.1, and Zigbee is using 802.15.4, and Wi-Fi is using 802.11. It carries either A, B, G or N. There are four variants will be there. Now these are the number. These number are prescribed in IEEE standard, and according to these standards, sort of rules are given under that. Okay, so that's why here these IEEE standards were followed with the help of these different protocols. Now, if you compare the frequency, every protocol is using the frequency in gigahertz, but here Bluetooth Classic and Bluetooth 4.0 is using 2.4 GHz. Zigbee will require varying frequency like 0.868 or 0.915 or 2.4 frequency will be required. And for Wi-Fi, it will be quite higher, like 2.4 or above, than up to 5 GHz frequency will be required. Then minimum raw bits rates will be here 1 to 3 Mbps data rate will be required. Data rate will be followed with the help of Bluetooth Classic. Then Bluetooth 4.0 will follow 1 Mbps rate. Then Zigbee will follow near about 0.250. Wi-Fi have a different Mbps rate. For B it is 11, for G it is 54, and for N it is up to 600 Mbps rate will be achieved. Then typical data throughputs, what will be the throughput of this particular technique will be near about 0.7 to 2.4 is quoted for Bluetooth Classic, 0.27 is quoted for Bluetooth 4.0, zero point 0.2 is quoted for Zigbee, and for Wi-Fi it is 7 for B, 25 for G, and 150 for N. Then maximum outdoor range in meters is given. Near about 10 meter is given for class 2, which is come under the Bluetooth Classic, and for class 1 it is 100 meters. Similarly, for Bluetooth 4.0 it is between these Bluetooth Classic is near about 50 meters. For Zigbee it is 10 to 100 meters, and for Wi-Fi it is 100 to 250 meters range. Outdoor range will be quoted. Then power consumptions will be medium in terms of Bluetooth Classic. For Bluetooth 4.0 it is very low. Zigbee is also having very low, and in Wi-Fi it is quite high because here coverage will be a larger one. Okay, so that's why it consumes larger power as compared to other one. Okay.
In case if you compare with battery life, Bluetooth Classic will be for in days. Bluetooth 4.0 will take in months to years. Okay, and Zigbee is also taking 1 2 years, and Wi-Fi in hours. Okay, because it required larger one power, so that's why Wi-Fi will consume a lot of power. Near about here, 7 network size, 7 node will be prescribed under the Bluetooth Classic. Under Bluetooth 4.0, there is undefined node network size will be there. In terms of Zigbee, in there are near about there are 65,536 node are possible under that. Okay, and similarly under Wi-Fi, near about 255 nodes are possible. Okay, now the same thing is given in another way. Okay, so this is again the comparisons between these three techniques like Bluetooth, Wi-Fi, and Zigbee. The same technique is again compared with these things. Okay, so I think this will be enough for your understanding. Okay, now I'm ending this video. Okay, so thank you very much for giving good listening. Okay,